Hello everyone. So in this video, we will solve this set of problems. At the beginning of every problem, you will see the full question with a 3-second timer like this. I urge you, I beg you to pause the video when you see the timer and try to solve the problem yourself first. This will really help you become more independent and better at problem solving. There is another important reason. If you solve the problem independently, it will really expand your thinking. And sometimes you will witness that your solution is better, smarter than mine. And those will be proud moments indeed. Alright, let's get started then. Remember to pause the video when you see the timer. Paula's weather app shows a diagram of predicted weather and maximum temperatures for the next 7 days as shown here. Which of the following represents the corresponding graph of maximum temperatures? Alright, so whenever you need to compare charts like this, try to notice two things. One is the direction, two, magnitude. Direction is also sometimes known as trend, meaning is something increasing or decreasing. Magnitude is the absolute value. Start with the direction first because that's easier to check. Alright, so let's go from Friday to Saturday. -1 to -4. So it should decrease. Here it is increasing, so this cannot be it. Here it's decreasing. It seems good. This seems good. This seems good. This seems good. Alright, so -4 to 0. -4 to 0. It should increase. This should increase here. This chart is already gone. This stays flat. It is not increasing, right? So this cannot be it. This is increasing here, increasing here, increasing here. All right. 0 to 0, it should stay flat, right? Okay, this stays flat here. This stays flat. This stays flat. All right. Similarly, we can check, but I quickly notice one thing, right? We can see that, this, the trend is different here. So let's check the last one. -3 to -5. It should decrease here, but it is increasing. So this cannot be it. This is decreasing. That is good. This is decreasing. That is good. All right. So this trend is matching. We are left with these two charts only, right? Now, I'll go to the magnitude, right? Because they have the same trend. So -1 to -4 is a difference of 3, right? -4 to 0 is a difference of 4. So this is the absolute difference between these two numbers. And this is the difference between these two numbers. All right. So if I go from here to here, right, this 3, this should be 4. If this is 3, this has to be 4. Similarly here, if this is 3, this has to be 4. Now, if I carefully take a look, right, if this is 3, if this is 3, this whole thing is way more than 4. It's more like 6 or 7, right? So this doesn't make sense. On the other hand, if this is 3, right, this is slightly bigger than this, so this seems like that can be 4, then E is the correct choice. How many integers are in the interval this and this? Alright, so 20 minus square root of 21, and then we have 20 plus square root of 21. The smart thing here is we don't need to find the exact square root of 21. We can just approximate it, right? So we know that 21 is between 16 and 25. 16 and 25 because I know the exact square root of that. Okay, so square root of 16 is going to be 4. Square root of 25 is 5. So square root of 21 is going to be 4 point something. All right. So this is going to be then 20 minus 4 point something. And this is going to be 20 plus 4 point something. Okay, so this is the range, right? So, and the number 20 is going to be somewhere in between. Now, how many integers are, so this is one integer, right there. This number, how many integers are from here to 20? So there are going to be 4 integers, right? There are going to be 4 integers because I'm just subtracting 4 point something. So there are going to be 4 integers. And here, how many integers are going to be from 20 to 20 plus 4 point something, right? So again, I'm adding 4 point something, so there are going to be 4 integers here, right? There are going to be 4 integers here. So the total is 4 plus 1 is 5 plus 4 is 9, right? So the total is 9. A is the correct choice. a cube with edge 1 is cut into two identical cuboids, what is the surface area of one of the cuboids? Alright, so let me make a quick drawing here. Okay, so this is going to be cut in exactly half. So there are two identical cuboids, right? Then the edge is 1, so the area is going to be 1 square is equal to 1. So the cube before the cut has 6 faces, right? So the total area is 6. If I cut it in half, that is, the area will be 6 by 2, but I'm exposing this surface, right? So I'm exposing this surface on the top, and that I know it has area of 1, right? Because that is going to be a square. So that is plus 1. So this is going to be 4, right? There is also another way you can take you can look at it. Once I make this cut, so I'm trying to find the area of this cuboid. The bottom is going to, the bottom surface is a square, the top surface is a square, so there is 1 plus 1, right? Plus I have 4 of these surfaces, right? The entire area is 1, so this is half. So half, but half times I have 4 of those, 4, right? So this also is going to be 4. So 2 plus 2 is 4. Either way, end up with 4. D is the correct choice. A large square is divided into smaller squares as shown. A shaded circle is inscribed inside each of the smaller squares. What proportion of the large square is shaded? Alright, so the circles are shaded. Okay, so let me call this region 1. So C1 is circle area. And then the square that inscribes it, let me call that area as A1. So that is square area. Square area, right? Okay, now let me, draw another picture here. This is a square and I'm inscribing a circle. Let me call the side of the square X, right? Let's see with the area of the circle by A with the area of the square. What is circle of the area of the circle? Is pi diameter square by 4, pi d square by 4, right? And diameter here is x, so there is pi x square by 4. And then what is the area of the square? That is just going to be x square, right? X square. So x square and x square will cancel out, so this is pi over 4. That means C is equal to pi over 4a, right? So the area of the inscribed circle C is pi over 4 times the area of the square that inscribes it. Alright, so let's keep that in mind. So here I want to find the proportion of the area of the last square that is shaded. Let me call this region 1, 2, 3, so on and so forth. So that is, I want to find C1 plus C2 plus the whole thing, the areas of the circle divided by total area. Let me call that A. The whole area, the big square is A. Now, C1 from here is pi by 4 A1, right? Pi by 4 A1. So this area of this inscribed circle is pi by 4 times the area of the square that inscribes it, right? Similarly, pi by 4 A2. C2 is going to be pi by 4 A2. So on and so forth, right? Divided by the total area of the big square. Now here, again, I can take pi by 4 common, and then this is A1 plus A2 plus, I'm just using the distributive property, right? By A, right? All that I did is took pi by 4 common outside, right? Now, what is A1 plus A2 plus everything? So A1 is this square, A2 is this, A3 is going to be this, so on and so forth. So that is going to add up to A, right? So all is A1 plus A2, everything that is all going to add up to A. So they will cancel out. So I'm left with pi over 4, right? Then E is the correct choice. Alright. Actually we didn't have to do all these calculations. Once we know from here, right? Once we have this relation, right? The area of the inscribed circle is pi by 4 times A. We know that, they are all the areas are divided into squares, right? So everywhere it is going to be pi by 4. So at the end, we will end up with pi by 4 anyway, right? But it's nice to see exactly how. We can also use algebra for this problem. Let me show you how. Let me assume the diameter of this circle as A, this circle is B, and this is C. Okay, and let me assume the length, side length of the square is 1. I can assume it to be 1 or x. Actually, it doesn't matter. Even if you assume x, you'll see that at the end it will just cancel out. But just to keep it simple, let me assume 1. Then A plus B is going to 1. This is the first equation. It is A and B, it has to be 1. That is the length of the square. Okay. Similarly, I can see that B is equal to 2C, right? B is equal to 2C, right? So this length B is 2C. Okay, so this is the second equation. And third equation is going to be, I can use this side, right? So this is also 1, right? So this is also 1. So that is a B and 3 of the smaller circles, right? B plus 3C is going to be 1. So this is my third equation. And so I have 3 equations, 3 unknowns. I can solve for A, B, and C. And once I have that, I want to find the proportion of the area that is shaded. That is the circles are all shaded, right? So I have one of the bigger circles. So that is pi A square by 4. So this is the area of the bigger circle. Plus I have 3 of these medium circles. 1, 2, and 3. So 3 times pi B square by 4, because B is the diameter of the medium circle. Plus, I have how many? 1, 2, 3, 4. 4 of the smaller circle. 4 times pi C square by 4. And the whole thing divided by the area of the large square, which is just 1, right? You will see that, once you solve for A, B, and C from these 3 equations and substitute here, you will end up with pi by 4. I'm not going to solve here. I'll leave that as an exercise for you to solve. But you should solve it and make sure that you end up with 4, the same answer. Actually, I just realized that you don't even have to solve these equations. Let me show how. Let me take pi by 4 out. So pi over 4. So what remains here is A square. Plus, if I take pi by 4 out, this is 3B square. Plus, if I take pi by 4 out, I have 4C square. Okay, what is A square? A is the diameter of the bigger circle, so A square is basically this big area, right? What is 3B square? B is the diameter of the medium circle, so B square is this area, and 3 of those, right? The 3B square. 4C square similarly. C is the diameter of the smallest circle, so C square is the area of that square, and 4 of those, right? 4 of those. And as you can see, this is nothing but the area of this big square, and the area of the big square is 1 times 1 is 1. So this whole thing is 1. So pi by 4 times 1 is pi by 4, right? We arrive at the same answer, and you don't even have to solve those equations. After the storm last night, the flagpole on our school building is leaning over. Looking from the northeast, its tip is to the right of the bottom point. Looking from the east, its tip is also to the right of the bottom point. In which direction could the flagpole be leaning over? Alright, so this is the base, this is the tip. Let me draw the directions again so that it's easier to explain. This is the north, south, east, west. Looking from northwest, so this is north and west. So if I look from this direction, if I look from this side, it is the tip is to the right of the base, right? So if this is the base, it's to the right. So this area is ruled out, cancelled out. It cannot be on that side. All right. Now, if I look from the east, if I look from this side, okay, let me go this side. If I look from this side, all right, it is again to the right. So that means this area is ruled out, right? If this is the base, it has to be right of that, right? Right of that. So this area is ruled out. So what is remaining is this area, right? So if the base is here, tip has to be somewhere here. The tip has to be somewhere here, and then the only one that matches is this one, right? All right, then A is the correct choice. A rectangular sheet of paper has length x and width y, where x is greater than y. The rectangle may be folded to form the curved surface of a circular cylinder in two different ways. Yes. What is the ratio of the volume of the longer cylinder to the volume of the shorter cylinder? All right. So if I have a circular cylinder, let me call the height to be h, the radius of the base circle as r. So there is area is pi r square times h is the volume. This is the volume, right? This is the volume. All right. So I have a rectangular sheet of paper. This is x. This is y. Let me grab a piece of paper. All right. So I can fold it either like this, right? So this is the shorter cylinder, or I can fold it like this. This is the longer cylinder, right? Now, if I do that, if I fold it like this, let me call the radius of the circle that forms is a, then x is going to be 2 pi a, because this is going to be the perimeter of the circle, right? And the perimeter is 2 pi a. Similarly, if I fold it this way, right? Let me call the radius of the base circle as b, then this is going to be 2 pi b, right? B is the radius of the base circle, right? So the volume of the longer cylinder, which way it will be longer? So if I fold it this way, it will be longer, right? Now volume is going to be r square. R is going to be y over 2 pi square, right? So this is going to be the radius of the longer cylinder, right? And the radius is y over 2 pi. So pi r square times h. H is going to be x, right? Now the volume of the shorter cylinder, so if I roll it this way, it's going to be the shorter cylinder. So there is again area of the base is pi r square. R in this case is going to be x over 2 pi, right? Because a is the radius. If I roll it this way, a is going to be x over 2 pi, and square of this, that is pi over r square times h. Height, if I roll it this way, height is going to be y, right? All right. So what is this? The pi cancels out. This 2 pi will cancel out, right? 1y will cancel this. This x will cancel this. So what is remaining is y over x. Y over x. Then B is the correct choice. That x is equal to pi by 4. Which of the following number is the largest? So x is equal to pi over 4. Pi is approximately 3.142. 3.142 by 4. So this number, as you can see, is less than 1. So when a number is less than 1, when a positive number is less than 1, higher the power, lower will be the number, right? So just to give an example, let's x is equal to 1 by 4. So x square is going to be 1 over 16, and then square root of x, which is also x to the power of half, is going to be 1 by 2, right? So when x is equal to 1 by 4, x square is 1 by 16, square root of x is half, and as you can see, higher the power, lower the number is, right? So higher the power, lower the number. So square root of x is nothing but x to the power of half. This is x to the power of 1 by 4. And this is the smallest power, right? So this will be the largest number. The key thing to realize here is we don't really need to calculate the exact value of that. We just need to notice that this number is less than 1, and then it's easy. How many 3-digit numbers from using only the digits 1, 3 and 5 are divisible by 5? You may use a digit more than once. Alright, so we have a 3-digit number. For a number to be divisible by 5, the unit place has to be either 0 or 5, right? But 0 is not one of the digits given, so this must be 5. Alright, now we can repeat, right? You may use the digits more than once, so this can be 1, 3 or 5, so 3 possible ways. This can also be 1, 3 and 5, so this is 3 possible ways. And so this 3 times 3, and there is only one choice for this, so this is going to be 9. C is the correct choice. What is the area of triangle whose vertices are PQ, 3P and Q, 2P, 3Q? Well, PQ are greater than 0. So let me draw a simple coordinate system. Alright, so this unit is P, this is Q. Alright, so P and Q, so this is one vertex, 3P and Q, so this is 1, 2, 3P and 1Q, so this is other vertex, 2P and 3Q, 1P, 2P and 1Q, 2Q, 3Q. So this is the triangle. The area of the triangle is half times the base. Base is going to be 2P, right? This is P, so this is 2P times height is going to be 2Q, right? So each unit is Q on the y-axis, so this is 2Q. So this cancels out, so this is going to be 2PQ. C is the correct choice. The parabola in the figure has an equation of the form here. For some distinct real number a, b and c, which of the following equations could be an equation of the line? So this is the line. Now if you notice, this point is on the y-axis and this point is on the x-axis, so we will take advantage of that. If I look at this point here x is equal to 0, right? So if I put x is equal to 0 here, y is c. So the coordinate of this point then is 0, c, right? Okay. Now for the straight line also, if I put x is equal to 0, I should get y is equal to c. If I put x is equal to 0, I will get y is equal to c, which is fine. If I put x is equal to 0, I should get c, but here is b, so this is not going to work. Similarly, this is a b, it should be c, this is not going to work. This is not going to work either. So we are left with these two choices, a and d. Now let's take advantage of this point here. So for this point, y is equal to 0. So here y is equal to 0. Now if I let me put y is equal to 0, solve for x, and then put it back in the equation of the parabola. That will be easier. So if y is equal to 0, 0 is equal to bx plus c. So this tells me x is going to be minus c by b, right? So here I'll get x equal to minus c by b. Now in this case, if I put y is equal to 0, so this is equal to ax plus c. So this will give me x is equal to minus c by a. Alright, so let me substitute this here and see which one makes sense. That's all, right? So then y is equal to, now here y is equal to 0, right? So 0 is equal to ax square plus bx plus c. Ax square is minus c over b square plus b, x is minus c over b plus c, right? So this b cancels out. So this is going to be a c square by b square plus Okay, so this is minus c and plus c. So this is going to cancel out, right? So this is going to be, so this should be 0, right? Now, we know that I can multiply both sides by b square. So this gives me ac square is equal to 0, right? I multiply both sides by b square. And then I divide both sides by a. So here, let's look at that. For ac square to be 0, either a has to be 0 or c has to be 0, right? Or both can be 0. But c is not 0. We know that this distance is c, right? So that is not 0, right? Then this tells me that a is equal to 0, right? But a cannot be 0. If a is 0, this term becomes 0, and then this is no longer an equation of a parabola, right? So this is the equation of a straight line, right? So a cannot be 0. So it seems like this cannot be possible, but let's double check this. In this case, if I substitute the value of x here, that is going to be 0 is equal to, because I'm looking at this point, right? So y is equal to 0, is equal to ax square plus bx plus c. So that is a x square is going to be minus c by a square plus b, x is minus c by a plus c. Okay, so this gives me 0 is equal to a c square by a square plus, so this is going to be minus bc by a plus c. All right, so I'm going to multiply. All right, so this cancels out, so I'm going to simplify it here. So this is c square by a minus bc by a plus c is equal to 0. I'll take bc to that side, so c square by a plus c is equal to bc by a, right? I multiply a throughout, so there is c square plus ac is equal to bc, right? Okay, I can cancel out c. There is that, so this basically gives me b is equal to a plus c. Okay, all right, so that can be possible, right? So b can be a plus c. All that we need is they are all distinct, so that can be possible. Then D is the correct choice. What fraction of all the divisors of 7 factorial is odd? There is a little bit number theory involved in this, so if we know that, it becomes really easy. So let me first explain that. Let n be a positive integer. This can be written in terms of prime factorization, like so: p1 to the power n1, p2 to the power n2, p3 to the power n3, so on and so forth. Where p1, p2, p3 are prime numbers, and n1, n2, n3 are positive integers. Okay, then the number of factors, let me call f of n, that is number of factors of n. This is going to be whatever this exponent is, n1 plus 1 times whatever this exponent is, n2 plus 1 times whatever this exponent is, n3 plus 1, and so on and so forth. So this is going to be the total number of factors. And a factor is also a divisor, right? So the total number of factors is same as total number of divisors. All right. Now, how many of these factors are going to be odd? I'll write O for odd, total number of odd factors of n. Okay. Now, when we multiply two numbers, when do we get an odd number? Every time we multiply even with an even, we get an even. Even times odd gives me even. Odd times odd gives me odd. So this is the only time when we multiply odd with odd, we get an odd number. Okay. So if p1, p2, p3 are prime factors, the only prime number that is even is 2. So let me replace this, the smallest prime number, as 2. Okay, so I'm assuming the P1, the lowest one, prime factor is 2. Like in case if 2 is not a factor, for example 9 is 3 power 2, there is no 2 is not a factor of 9, right? In that case n1 will be simply 0 and that is fine. Okay, now if this is the case, right, how many odd factors will be there? The odd factors will come only from this part, right? It will not come from this part, right? Because anytime we multiply a even number with something, it always becomes even, right? So the total number of odd factors will come only from this part, so which is going to be nothing but this is n2 plus 1, right? This is n2 plus 1, and then similarly n3 plus 1, and so on and so forth, right? So these are going to be the number of odd factors, right, of the number n. Now we don't need it here, but I'm just writing here just for the sake of completion. Let's say number of even factors. So what is this going to be, right? A factor is going to be either even or odd, right? So number of even factors is then going to be the total number of factors n, f of n, minus the number of odd factors, right? So this is going to be the number of even factors. All right, so again, this is pure number theory. If you already know about it, that's great. If not, then now you do. All right, so we will make use of this. Now I can write, so I need to, let's first find the prime factors of 7 factorial, right? So 7 factorial by definition is going to be 1 times 2 times 3 times 4 times 5 times 6 times 7. So this is what is 7 factorial, right? This is 7 factorial. This is a factorial sign. Okay, now I want to make the factor, write down the factors as prime number. So 4 can be 2 times 2, and then 6 can be 2 times 3. Okay, then 7 factorial becomes, how many 2's are there? 1, 2, 3, 4. 2 to the power 4. How many 3's are there? 1, 2, 3 to the power of 2. And then what else? There is 1, 5. All right, and then there is 1, 7, right? So this is the prime factorization of 7 factorial. 2 to the power 4, 3 to the power 2, 5, and 7. All right, okay. Now we can just apply this formula, right? The what fraction of all the divisors of 7 factorial is odd. So the total number of factors is fn, right? So let me just write here. So we want this fraction, right? F of n, and on the numerator I want the number of odd factors, that is f odd of n, right? So this is going to be simply f of n is simply, I take all the exponents, like add 1 to them and multiply together. So exponent is 4 to the 5 is same as 5 to the power 1, 7 is same as 7 to the power of 1, right? So this is going to be 4 plus 1 times 2 plus 1 times 1 plus 1 times 1 plus 1, right? So that this is going to be on the numerator 4 plus 1, 4 plus 1, and then 2 plus 1, and then 1 plus 1, and then again 1 plus 1, right? Okay. Okay, now how many odd factors? Odd factors will come only from these, right? Not from here, as we already explained here. So this is 2 plus 1 times 1 plus 1 times 1 plus 1. So that is 2 plus 1 times 1 plus 1 times 1 plus 1, right? And as you can see, all this cancels out, right? So this just leaves me with 1 over 5, right? Then D is the correct choice, right? So again, this comes from number theory. So if you already know this, you can straight away apply it like this and you are all set. I mean, first find the prime factorization and then apply this and you are all set. If not, then this is where it comes from. Now notice one thing here. Everything cancels out except what was power of 2, right? So when you are doing the prime factorization, if you can only find out what power of 2, then you are all set. You don't have to actually find the other prime factors. So whatever the power of 2 was, right, that plus 1 over that, is going to be the answer. If A is this and B is this, what is the set of all the numbers of the form lowercase a plus lowercase b, where lowercase a belongs to uppercase a and lowercase b belongs to uppercase b? All right, so let me, so this is a union symbol. So I'll first take this part. I'm going to add this to this part. Now, what will be the range? Like if I add this set to this set, the range is going to be, I add the lower number to the lower number. There's 0 plus 1 is 1, and then higher to higher. So 1 plus 2 is 3, right? So this is going to be the range if I add this to this. Similarly, if I add this to this, it's going to be 0 plus 3 is 3, and then 1 plus 4 is 5, right? Okay, next I will take this range. So, and then I'm going to add this to this first. So 2 plus 1 is 3, right? And then 3 plus 2 is 5. Okay, one last is remaining. I'm going to add this to the last one. So 2 plus 3 is 5. And then 3 plus 4 is 7. Okay, so this is going to be my final range. So this is union. This is all union. Now, is there any duplicate? I can see that this is duplicate, right? 3 to 5, 3 to 5. So this is duplicate. So I don't need this. I can basically get rid of this, right? So the final range is going to be 1 to 3, 3 to 5, 5 to 7. And there is 1 to 3, 3 to 5, 5 to 7. Then D is the correct choice. How many 3-digit natural numbers have the property that when their digits are written in reverse order, the result is a 3-digit number which is 99 more than the original number? All right, so let me assume that the original number is A, B, C, and when I reverse it, it's going to be C, B, A. Now I will use the place value to write the value of this. So this is the 100 place, so 100 times A, 100A, plus similarly this is 10's place, so 10B plus C. So what is the value of this number? Similarly is 100C plus 10B plus A. Now, so this number, like this value is 99 more than this. Then what I'll do is use the negative symbol here and then add it up. So 100C minus C is 99C, and then 10B minus 10B, they will cancel out. A minus 100A is minus 99A, and this is given to us as 99 more, right? So this is 99, so 99 will cancel out, then C minus A is going to be 1. Okay, so this is the condition that needs to be met, right? So this is the original number. B can be anything, right? B can be anything. And what are the different 1-digit numbers? 0 to 9, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So B, the middle number, can be anything. So there are 10 possible choices for that. And for each of that, what can be A? So let me write this as C minus A is 1. So the C is equal to A plus 1. Right? C is equal to A plus 1. That is the condition that needs to be met. Can A be 0? A cannot be 0 because then this becomes a 2-digit number, right? So A cannot be 0. A can be 1, right? Yes, A can be 1 plus 1 is 2, then C will be 2. If A is 1, C is 2, which is fine, right? So it can be 1. Similarly, A can be all the way until 8, right? Can A be 9? If A is 9, C will be 10, then C becomes a 2-digit number. So A cannot be 9. Then the possible choices for A is from 1 to 8. So there are 8 choices for A. Now, once we choose A, the choice for C is fixed, right? So there is, for each of this, the C has only one choice, right? So the total number is then 8 times 10 times 1. So this is going to be 80. D is the correct choice. The first 1000 positive integers are written in a row in some order, and all the sums of the 3 adjacent numbers are calculated. What is the greatest number of odd sums that can be obtained? So we have first 1000 positive numbers. So they're going to be 1, 2, 3, 4, all the way to 1000. So as you can see, there will be equal number of odd and even integers. So these are going to be odd, these are going to be even. So there will be equal numbers. So 500 odd and 500 even. So when I add three numbers, when do I get an even sum and when do I get an odd sum? So let's see. So if I have even plus even plus even, this will be always even. Even plus odd, this will be always odd. And here for the summation order doesn't matter, so I can put odd anywhere. So even plus odd plus odd. Odd plus odd will be even, plus even is even, and then I have odd plus odd plus odd. Odd plus odd will be even, plus odd is odd. All right, so these are the all the ways I can add three numbers, right? And out of that, these are the only two ways I get the sum to be odd. Either I have all three odd numbers or two even and odd numbers. So I want to make use of this fact also to use up some of the even numbers to get the odd sum, right? So what I want to do is for every two even, I want a odd. So I can do it like this: even, and then odd, right? So, and I want to arrange the number such that for every two even, I have a odd. So I can start like that. I can start also even, odd, even, or I can also start odd, even, and even. All right. Now, if I do it like this, so this is the first three for the first three pairs, first three group, and the second three for I want a odd for two evens, right? So I want this even, so two even and one odd. For the next three, I already have a odd, so I want this to be even. For the next three, I have two even, so I need a odd, and so on and so forth. So as you can see, this pattern is going to repeat. This pattern is going to repeat all the way to even, and odd. And then, so I have used up all the even until this point, and then these are all going to be odd, right? Okay, so how many numbers are here? Okay, so let me put this boundary here. So I have used up all the even, so there is 500 even, and for every two even I have a odd, so that means 250 odd numbers. So I have used up 750 numbers here, and these are going to be the rest 250 odd numbers, right? So just like the logic here, if I start with even, odd, even, then this pattern is going to repeat: even, odd, even, all the way to even, odd, even. And the remaining 250 odd numbers are there. Same here: odd, even, odd, even, all the way to odd, even, and then 250 odd numbers are there. Okay. Now the way I have arranged is, if I take any three consecutive numbers, right, I will have two even and a odd. So I will always get the sum to be odd, right? That's what we figured out there. Except, let's check at the boundary. Okay. Now this is odd, of course, because that's how I have arranged it. But if I take this, the next three, even, odd, and odd, so this will be a even sum, right? Now if I take this three, odd, 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 this is going to be odd, so that is fine. So I have, if I do it this way, I have one even sum at the boundary. If I do it this way, so this odd, even, and odd is going to be even, right? Then even, odd, odd, this is going to be even, right? So this way I get two evens at the boundary, and after this, odd, 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 so here is always going to be odd anyway, right? So if I do it this way, odd, even, even, of course this is going to be odd. But if I take this, even, odd, this is going to be odd. Even, odd, and odd, this is going to be even, right? And then odd, odd, and odd, from here on I will always get odd. So this is one even. So if I start the pattern like this, I get one even at the boundary, If I start the pattern like this, I get 2 evens at the boundary. If I start it like this, I get 1 even at the boundary. And I want to maximize the odd sum, so I do not want to do this way. So this is one way, this is the other way. And in either case, I get only 1 even at the boundary. Every other sum of consecutive 3 is going to be odd, right? Now, how many total sums will be there for 1000 numbers? For 1000 numbers, right? So 1, 2, 3, all the way to 1000, right? So this is the first 3. The second 3 will be 2, 3, and 4, so on and so forth, all the way until the last 3 will be 998, 999, and 1000. So this is going to be the last 3, right? So how many groups of 3 are there? So there will be 998 groups of 3, right? And then again, once I reach at 998, here I don't have any more 3, right? I have only 2. So I cannot make a groups of 3 anymore from here. So there are total, like if I have 1000 numbers, not necessarily in the sequence 1, 2, 3, 4 like that, but in any order, right? No matter how I arrange them, I will have 998 groups of 3, right? 998 groups of consecutive 3, right? And out of that, if I arrange it like this or this, right, I have 1 even at the boundary, right? So that is the least number of even I can get. If I order it like this, I'll have 2 even. So I do not want to do it like this, right? I'll do it like this or this, and that in that case I'll have 1 even at the boundary. So I'll take that out, -1, so that is 997. So this is the maximum number of odd sums I can get, right? Then A is the correct choice. A large triangle is divided into smaller triangles as shown. The number inside each small triangle indicates its perimeter. What is the perimeter of the large triangle? So we want to find the perimeter of this. So 20 is perimeter of this triangle. So let me, if I travel the length once, I'll mark it once. So 20 means this plus this plus this. Similarly, 13 means this plus this and this. Similarly, 12 is this, this, and this. 9 is this, this, and this. 15 is this, 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 and this. So I'm assuming this side is, divided into 2 segments. And then 11 is this, this, and this. 10 is this, this, and this. Now, if I add all the numbers together, right, that gives me the perimeter plus these 2 inside triangles, right? This triangle and this triangle, perimeter of those are added twice extra. So I will take that away. So I have 20 plus 13 plus 9 plus 13 plus 9 plus 12, 15, 10, 11. 15, 10, 11, right? So I'm adding all the numbers, right? But that I have added this triangle twice extra and this triangle twice extra. So I'll take away -2 times 13 and then 2 times 15, -2 times 15, right? So that should give me the perimeter of the outside triangle. And then of course I can take away 113 and then 115, and then if I take away 13, so this is 7 will remain here. And then if 15, what I will do is 12, let me take away 12, then what I have remaining is 3, and then I take away 3 from here is 4. So what I have is 4 plus 9 is 13, plus this is 21. So this is going to be 34, right? Then C is the correct choice. An infinite list of numbers has this property that for each positive integer n, the average of first n terms is n. How many terms are less than 2021? All right. Okay, let me say the terms are a1, plus a2 plus all the way to an, and the average of that, so that is divided by n because there are n numbers, and this is n. That's what is given to us, right? Now if I multiply n with both sides, so this is going to be a1 plus a2 plus an, this is going to be n square, right? So I'm multiplying n to both sides. All right. So if you look at this, it basically tells that n numbers add up to n square, right? So which numbers have that property? This is again from the number theory. It's something nice to know. First, n odd numbers add up to n square. Okay, first odd number adds up to 1 square. First two odd numbers, 1 plus 3, they add up to 2 square, as you can verify. First three odd numbers, 1 plus 3 plus 5, right? They add up to 3 square, so on and so forth. So first n odd numbers add up to n square. So the first n numbers have that property, right? So there is again something nice to know. Now once we know that, right, how many odd numbers are there before 2021? So 2021 by 2 is 10, 10, and remainder is 1, right? So there are 10 odd numbers, right? Before the number 2021. Then how many terms are less than 2021? So that many, right? That many terms, that many odd numbers are less than 2021. Then C is the correct choice. In the 5 by 5 square zone, sum of the numbers in each row and each column is the same. There is a number in every cell, but some of the numbers are not so. What is the number in the cell marked with a question mark? So what is this number here? So, if I assume a different variable for each of the missing cells, there will be too many variables and too many equations to solve, right? And in math competitions, they typically never give a problem where you have to solve too many equations with too many variables, right? So there must be a smarter way. And the smart way here is, let me assume just a few of these. Let's say this is A, B, this is C and D, and the missing is X. Okay. Now the sum of this column, let me say S. So this column also should add up to S. Similarly, this row should add up to S. This row should add up to S, right? That is given to us, right? So the idea here is, I'll equate the sum of these two columns with the sum of these two rows. Then the variables will be the same on both sides and they will cancel out. So what will be remaining is just X. And so it will be easy to find. So let me do that. So let me add this column with this column. 16a25, so 16 plus a plus 25, and then d plus 4 plus 22b1, 22 plus b plus 1, and plus c plus x. X is the unknown. This has to be same as sum of these two rows, 20a21, 20a21, and b plus 2 plus 24d5, 24d5, c and 6. Okay. Now as you can see, a on both sides cancel out, d on both sides cancel out, b on both sides cancel out, c on both sides cancel out. All right. Now this is 20 and 5 is 25, that cancels out. Then say 6, 10 will be remaining here, and then this is 21. I'll have only 1 remaining here. What else? So this is 4. Only 20 will remain here, right? So this 10, only 10 remains there. What else? So I have 1 plus 1 is 2. This is 1 plus 1 is 2. So that cancels out. So what else is remaining here? Okay, everything is gone. Only thing remaining is X. and on this side only 10, right? So x must be 10, right? Then B is the correct choice. A piece of string is lying on the table. It is partially covered by 3 coins as seen in the figure. Under each coin, the string is equally likely to pass over itself like this or like this. What is the probability that the string is knotted after the ends are pulled? All right. So here, this side is on the top. Here, this side is on the top. Okay. So what is the total number of ways they can be arranged? Here there are 2 possible ways, either this or this, right? And for each of those, there are 2 possible ways here, again like this or this. Again here, there are 2 ways similarly, right? So this is the total number of ways. Now, in which of those ways it will be knotted? Now, as you can imagine, this is the main junction, right? So this is the main junction. So let me draw in a thicker line if this side is up. Okay. Now, if this side is up, the only way it will be knotted is here. This string has to be down. This has to be up. And similarly, if this string is down here, it has to be on the top, right? And then when you pull, it will be knotted, right? Now, let me draw another picture here. Okay. Now, in this case, here, this is on the top. In this case, if this is on the top, I'll draw it thicker. Then if this is on the top, here it has to be on the bottom. That means this has to be on the top. And here, if this is on the bottom here, this thing has to be on the top, right? And that is the only way, if you pull, it will be knotted, right? Okay. So these are the only 2 possible ways it can be knotted. So there is 2 on the top. So this gives me 1/4. All right. So try to imagine this situation here, right? You can actually experiment with a rope at your home. If I have the rope like this, let's say this side is on the top, then this has to go inside and the other side has to come up, and then when I pull, it will be knotted. On the other hand, if I have it like this, right? So this side is on the top. So if it remains on the top, right? So and the other side, whether it comes up or goes down, doesn't matter, right? When you pull, it is not going to be knotted, right? So I definitely encourage you to, whenever possible, it is always nice to, experiment it yourself to understand that really well. So in this case again, right, there are total 8 possible ways, and the ways it will be knotted is these 2 configuration only. Then we end up with 1/4, and then B is the correct choice. A naughty pop grabs the end of a roll of toilet paper and walks away at a constant speed. All right. Which of the functions below best describes the thickness y of the roll as a function of the unrolled part x? So y is the thickness of the roll and x is the unrolled part. So the first thing to notice is as you start pulling, right, it will unroll and the y will get smaller and smaller. So with increasing x, y has to decrease. So here y is increasing, so this is definitely not possible. Now in this case, the y is going up and down and up and down. This is definitely not possible. The roll is not going to get smaller and thicker and smaller and thicker. It will always get smaller. Okay. Now what remains to find out is which of this is true. All right. So let me draw the roll here. Let's say this is the roll, and I'm pulling it to unwind it one time, right? So let's say this much, and let's say that is in time t. This distance is one time around. Now, when the roll is smaller, right? If I have to pull the same distance, because it has to go same distance in the same time, because the pop is going at the constant speed. So if I have to pull the same amount, right? For the same amount, since the now the perimeter is smaller, I have to unwind it multiple times, right? So I have to unwind it multiple times, meaning the y, the thickness is getting smaller faster, right? Here the y is getting smaller slower, this is faster. The y will get smaller faster, right? So in the beginning, when we start pulling, the y has to decrease slower, and towards the end it will be faster. Here, and how do we know which is slower or faster? By the slope, right? Here the slope is same as the slope here. So this graph tells me that the y is decreasing at a constant rate, which is not true, because at the end it will decrease faster. So this is not true. So here the slope is larger, here the slope is slower here. So this tells me that y is decreasing faster in the beginning, right? That is not true. The y is decreasing slower in the beginning. So this is not true. So this case, the slope is smaller here, the slope is larger here. This tells me y is decreasing slower, and towards the end, as x increases, the rate is faster and faster. So this matches with the expansion there. Then E is the correct choice. The diagram shows three squares, this, and this, like so. They are placed together edge to edge. Points P, T, and X lie on the same straight line. All right, P, T, and X. So let me draw that line. The area PQRS is 36, PQRS is 36, TUVR is 16. What is the area of the triangle PXV? All right, PX, this is V. So what is the area of this triangle? Since the area is 36, the side length has to be 6. So 6 square is 36. And the side length here has to be 4, right? Because the area is 16. Now, once I know the side length of this square, I know the coordinates of this point. I know the coordinates of this point. Now, I can write down the equation of the straight line and then try to find the size of this square, right? So that is one way. But I think there is an easier approach. So since this is a straight line, this is going to be the slope, right? This divided by this, the slope, that has to be same as this divided by this, right? So that is the slope of the straight line, and so slope of the straight line should be same anywhere, right? So let me write this. So what is this length? This length is, the whole length is 6 and this is 4, right? So 6 minus 4 over, what is this length? This length is 6. So that should be equal to this. So let me call this distance y, right? So that has to be y divided by this distance, that is 4, right? That is 4. So this is 6 minus 4 is 2. So this is 1/3. So this tells me y is equal to 4 by 3. Y is equal to 4 over 3. Okay. Now I'll do the same thing here. Calculate this slope here. So that is this divided by this. What is this length? If I assume the square has side length A, then this is going to be the whole thing A minus this, right? So A minus y over this. This is A, because this is also a square. This has to be the same slope, right? So slope is 1/3 here. We have computed that 1/3. So let me multiply A on both sides. So A minus y I know is 4 by 3. I'll take A to the other side. So that is A 1/3, right? I multiply 3 all the way. So that is 3A minus 4 is equal to A. I bring A to this side, take 4 to that side. So there is going to be 2A is equal to 4. This tells me A is going to be 2. All right. All right. So now I know this length. Now, how do I find the area of this triangle? Again, I know the coordinates of all the points, so there are several ways we can do that, but let's do it the simplest way. I can express this area. Let me change the color. So if I take the whole thing as a trapezoid and then subtract this area, right? This is triangle, this is a triangle. So this whole thing is a trapezoid and then subtract these two triangles, right? So the area of the trapezoid is this length plus this length by 2. So this length is what? This length is 6 plus what is this length? So A is 2, right? We already found out A is 2 and this whole thing is 4. So this has to be 2. So this has to be 2. So 6 plus 2 by 2 times this height. What is this height? This is 6 plus 4 plus 2 is 12. Okay. So this is the area of this trapezoid minus area of this triangle. Area of this triangle is half base time height. So half, I can take base as this. So that is 6 plus 4 is 10. Then height is going to be this, which is 6 times 6 minus area of this triangle. That is again half times base is 2 times height is also 2, right? So how much do I have? So this is 6 plus 2 is 8 by 2 is 4. So this whole thing is 4. So 12 times 4 is 48. Let me write here. So this is 48. 12 times 4 is 48. And this is going to be, this is 3 times 10 is 30 minus 30, right? And here 2 cancels, so just 2 minus 2. So this is going to be 48 minus 30 is 18 minus 2 is going to be 16, right? So that is the area of this triangle, right? Then C is the correct choice. The figure shows the graph of a function f from -5 to 5 in the closed range to R real numbers. How many distinct solutions does the equation f of x is equal to 0 have? All right, so let me just move to this side for this question. So this is x, this is f of x. All right, so we have f of x is equal to 0. So for what values of this, f of that variable is 0. So f is 0 when x is -4, -2, 2 or 4, right? So this has to be -4, -2, 2 or 4, right? Then f of x has to be this, any of these values, -4, -2, 2 or 4. Now the next question is, at what values of x f of x is this? So at what values of x f of x, which is on y-axis, are this? So let me just draw it. -4. So f of x is -4. So this is -3. -4 is going to be somewhere here, right? So this is -3. So this is -4. And then -2. So f of x is -2 somewhere here. Then 2 is somewhere here. And then 4. But is 4 somewhere here. All right. So at what values of x f of x is going to be this? So we can simply trace the curve here. So this is one value of x. This will be second values of x. That is 2. And then if we go here, this is going to be 3, 4. And then this is 5, 6, 7, and 8. So at 8 distinct values of x, f of x will be -4, -2, 2, and 4, and for which f of x will be 0. So there are 8, right? Then E is the correct choice. So there is another approach to this problem I wanted to discuss. So in the last approach, I went from outside to inside, meaning I started with the outside f is equal to 0. From there we figure out what is f of x. From there we figure out what is x. So in this approach, we'll go from inside to outside. So we'll start with the range of x that is given to us. From there, we'll figure out what should be the f of x range. From there, we'll see when f is equal to 0. All right, so let me write it down. This is x. this is f of x, this is x, this is f of x. Okay, I can also call f of x is equal to g. So let me call f of x is equal to g. So if this is g, this is f of g, which is f of g is f of x, right? So that is what is given to us. All right. Okay, so let's start from this end. X is equal to -5. So I will go from -5 to 5, but I will go in smaller segments so that it's easier to trace. So I'll go from -5 to 4 first. -5 to 4. So when x is -5, y is 5, or f of x is 5. When x is -4, f of x is 0, right? So when g goes from 5 to 0, when g goes from 5 to 0, how many times f of g is 0? This is one time, this is second time. That means in the original range of -5 to 4, there are two distinct solutions. All right. Similarly, now I'll go from -4 to somewhere about this point here. So this point is -2 point something, -2 point something. So when x is equal to -2 point something, y is somewhere here, that is -2 point something too. So when g goes from 0 to -2 point something, 0 to this point, how many times f of g is 0? One time. So there is one distinct solution there. Now I'll go from here to here, so there to -2. So when I go from here to here, what is the value of f of x here? This is 0, right? So now for g, I will go from -2 point something to 0. So -2 point something is here to 0. F of g becomes 0 one time. So there is one distinct solution there, right? Next, I will go from -2 to 0, right? So when it is 0, f of x is 3. So I'll go from 0 to 3 for g. So 0 to 3, f of g becomes 0 one time. So there is one distinct solution there. Then I'll go from x is equal to 0 to 2. 0 to 2 now. When I go to 2, f of x is 0. So when g goes from 3 to 0, 3 to 0, f of g is 0 one time. So there is one distinct solution there. Now we'll go from 2 to 3. So 2 to 3. So in 2 to 3, when x is 3, f of x is -1. So when g goes from 0 to -1, 0 to -1, this curve doesn't cross here, right? So then there is zero distinct solution there. From 3 to 4, so 3 to 4, at 4, f of x is equal to 0. Then -1 to 0 for g, -1 to 0. Again, this curve doesn't cross here. So there is zero distinct solutions there. Now from 4 to 5, so last point is 5. At 5, f of x is 5, right? So when g goes from 0 to 5, 0 to 5, there are two distinct points when f of g is 0. So then there are two distinct solutions here. Now I can just count it up. 2, 3, 4, 5, 6, 7, 8. So there are 8 distinct solutions, same as before. The numbers 1, 2, 7, 9, 10, 15 and 19 are written down on a blackboard. Two players alternately delete one number each until one number remains on the blackboard. Right? So one number remains. The sum of the numbers deleted by one of the players is twice the sum of the numbers deleted by the other player. What is the number that remains? Okay, let me call the players x and y. Each start deleting one alternately. How many numbers are there? 1, 2, 3, 4, 5, 6, and 7. So there are total 7 numbers. So each must delete 3, right? All right. Now, if this sum is S, the sum of all the numbers deleted by one player is s, then this sum has to be 2s, and that is what is given to us, right? So the sum of the all the numbers deleted is going to be s plus 2s. So this is going to be 3s. So that is the first condition, meaning the sum of all the deleted numbers has to be a multiple of 3. So that is the first condition. The second condition is, so these three numbers, three of the numbers should add up to s, and the other three must add up to 2s, right? So this is the second condition. All right. Next, what we can try to do is, so these are the choices that are given to us. Then we can try to check each choice at a time and see if it makes sense. Now, before doing that, let's try to do a smart thing. Since we have to check the divisibility with 3, right? So let's see the individual numbers if they are divisible by 3. Now, 1 and 2, they are not one of the choices, so we can combine them together. So 1 and 2 is 3, and that is divisible by 3. So whichever number is divisible by 3, I'll try to put an underline. 7, if I divide 7 with 3, I'll have one remainder. 9 is divisible by 3, so I'll put an underline. 10, if I divide with 3, I'll have one remainder. And then 15 is divisible by 3. 19, if I divide with 3, then 1 will be remainder, right? All right. Now, notice one thing here. 7, 10, and 19, they are individually not divisible by 3. But if I add them together, the remainders of 1, 1, and 1, so all the remainders together are 3, and that will be divisible. So the sum of 7, 10, and 19 will be divisible by 3. That means those 7, 10, or 19, one of those cannot be the remaining number, right? Because if one of these is a remaining number, the rest of the numbers is not going to be divisible by 3, right? That means we can cross out 7, 10, and 19 because one of those cannot be the remaining number. Again, that is because if one of them is a remaining number, the rest of the numbers is not going to be divisible by 3. All right, so we are left with two choices and we can check one at a time. So let's say 9 is remaining. If I add up the remaining numbers, 1 plus 2 is 3, plus 7 is 10, plus 10 is 20, and this is 35. So 35 plus 19, this gives me 54. So 54 divided by 3, this gives me 18, right? So I should be able to add 3 of the numbers and get 18. Can I do that? Yeah. So if I take 15 plus 2 is 17, plus 1 is 18. So if I add these 3 numbers, right, I get 18, right? So seems like B is the correct choice, but let's double check 15. What if 15 is the remaining number, right? So let me just erase this. Let's say 15 is the number that is remaining. In that case, if I add this up, so this is 7 plus 2 is 9 plus 1 is 10. 10 plus 10 is 20. This is 29 and 19. So 29 plus 19 is going to be 58, right? So 58 is again divisible by 3. Let me divide it. 58 by 3 is going to be, no, that is not. Okay, this should be 48. This should be 48. Now this is going to be 16, right? Now, can I add 3 other numbers to get 16? There is no way I can add 3 other numbers to get 16. So again, D cannot be the correct choice, then B is the correct choice. The function f is such that fx plus y is fx times fy, and f of 1 is 2. What is the value of this long expression. All right, so somehow we want to simplify this using those two. So let me write this here. F of 2. Can I write f of 2 as f of 1 plus 1, and then f of 1 is the denominator, plus f of 3, I'll write this as f of 2 plus 1 divided by f of 2, right? All the way, I want to write this as f of 20 plus 1 divided by f of 20, right? Okay, so I'm splitting the top number such a way that I get a number that is same as below, so that I can use this, right? Then this is going to be f of x plus y is fx times fy. So this is going to be f of 1 times f of 1 divided by f of 1 plus this is f of 2 times f of 1 divided by f of 2 plus all the way is f of 20 times f of 1 divided by f of 20, right? Then I can simply cancel this out. So what is remaining? This is going to be f of 1 plus this is also f of 1. So every term is f of 1. And how many of those terms are there? So I'm starting from 2, I'm going to 2021. So there is 2020, right? So 1 less because I'm starting from 2. So there is 2020 of the term. So this is times 2020. But what is f of 1? F of 1 is 2. So this is 2. So this is then 40 is the final answer, right? So that means none of the previous, right? Because none of this matters here. 5 kangaroos named A, B, C, D, E have one child each named lowercase a, b, c, d, e, not necessarily in that order, all right? In the first group photo shown, exactly 2 of the children are standing next to their mother. So this is the first group and 2 kids are standing next to their mothers. In the second group, exactly 3 of the children are standing next to their mothers. So 3 children are standing next to their mothers. So whose child is A? All right. So for problems like this, often it helps to draw a picture that is a little easier to visualize. So let me draw it here again. These are the mothers A, B, C, D, E, and these are the children A, B, C, D, E. So let me connect the group 1. From group 1, A is connected to D, B to A, C to B, D to C, E to E, all right? And then I'll draw the second group here. These are the mothers again, A, B, C, D, and E, and the connection is A to B, A to B, B to E, B to E, C to D, C to D, D to A, D to A, E to C. E is connected to C. All right. So what we can do is assume a pair of 2 from here and assume that their kids are standing to them, and then see if that makes sense from the other group, right? So how many pairs of 2 we can have? So that is going to be AB, AC, AD, AE, and then BC, BD, BE, and then CD, CE, and then DE. There are going to be total 10 pairs. So basically I'm choosing 2 from 5, that is 5 choose 2, so this is going to be 10, right? All right. So now let's assume that, let me change the color. let me assume that AB is correct. So A and B have their kids next to each other. So that means D is connected to A and A is connected to B. Now let's see if it makes sense from group 2. So in group 2, if A and B are correct here, I'm expecting C, D, E should be correct from the other group, because on the second group, 3 are correct, right? Now C is connected to D. That cannot happen because I have already assumed D is child of A, right? Then this assumption is not correct. All right. Next, I'm going to assume AC is correct. So here A and C are correct. That means A is connected to D and C is connected to B. So if I assume A and C are correct here, then from this group, B and then D and E have to be correct, right? Now B is connected to E, which is fine. D is connected to A, that is fine. E is connected to C, that is fine. So it makes sense. There is no contradiction there. So looks like AC is valid. Actually, similarly, you can check the other pairs of 2, just like we checked the first one, and see that they will not make sense. I have already checked those. So this is the correct from the first group, A and C. That means whose child is A? So A is child of D, right? Then D is the correct choice. The solid shown in the diagram has 12 regular pentagonal faces, the other faces being either equilateral triangles or squares. Each pentagonal face is surrounded by 5 square faces and each triangular face is surrounded by 3 square faces, like so. John writes 1 on each triangular face, 5 on each pentagonal face and -1 on each square, like this. What is the total of the numbers written on the solid? So we need to find the total. So we have 12 pentagonal faces. All right, and notice that for each pentagon there is 5 squares. 1, 2, 3, 4, 5. So for 12 pentagons, 12 times 5 squares. But also notice that each square is shared by 2 pentagons. So this pentagon has this square, this pentagon also has this square, right? So I'm double counting all the squares. Therefore, I have to divide it by 2 to get the actual number of squares, right? Actually, there is also another way to think about it. So there are 12 pentagons. So for 12 pentagons, there are 12 times 5 sides. And there is 1 square for every 2 sides, right? So for every 2 sides, there is a square. So 12 times 5 by 2. So that's another way to think about it. Similarly, notice that each pentagon has 1, 2, 3, 4, 5 triangles, right? So 12 pentagons will have 12 times 5 triangles. But each triangle is shared by 3 pentagons. So this pentagon has this triangle, this pentagon will also have this triangle, this pentagon will also have this triangle. So I'm triple counting the triangle, so I have to divide it by 3, right? There is also another way to think about it. Again, 12 pentagons will have total of 12 times 5 corners. So there are, and every 3 corner will have a triangle. So 12 times 5 by 3, total number of triangles. Now it is all straightforward. So I have 12 pentagon, and this is going to be 30 squares, and this is going to be 20 triangles, right? So I have 12 pentagon, and each pentagon is 5. So 12 times 5 is 60, and I have 30 squares, and each square is -1. This is -30, and then I have 20 triangles. 20 times each triangle is 1 point, so this is 20. So if I add it up, this 60 minus 30 is 30, plus 20 is 50 total points, then B is the correct choice. On a circle, 15 points are equally spaced. We can form triangles by joining any three of these. Congruent triangles by rotation or reflection are counted only one triangle. How many different triangles can be drawn? Alright, so we have total of 15 points. We have already used 3 points for the triangle, so minus 3 is equal to, we have 12 points that are remaining, right? So somehow we have to distribute these 12 points in 3 groups. One group can go here, another group can go here, another group can go here, and this group can have 0 to 12 points. Similarly, this group can have 0 to 12, this group can have 0 to 12. All right, so let me start writing down the different possibilities. So these are the 3 groups. On the first, I will count this as 0, and then the second group can have 0, then this will have 12. The second group can have 1, then this will have 11, 2, this will have 10, 3, this will have 9, 4, this will have 8, 5, this will have 7, 6, this will have 6, then 7, this will have 5, but 7 and 5, 5 and 7, they will be the same, congruent, so this is ruled out. All right, so how many we have here? 1, 2, 3, 4, 5, 6, 7. There are 7. All right, next, let me start another group here. So here I have already accounted for 0. Let me start with 1 now. If I have 1, this can have 0, then this will have 11. This can have 1, 10, or 2, 9, 3, 8, 4, 7, 5, 6, 6, 5. But 6, 5 and 5, 6, they are the same. So this is ruled out. Also notice that, 1, 0, 11, 1, 0, 11. This is already accounted here. So this is also ruled out. So I have total of how many? 1, 2, 3, 4, 5. 5. All right. Similarly, let me draw another group here. 0 is gone, 1 is gone. I'll start with 2 here. Then I can have 0 here. Then I'll have 10. Basically, the 3 numbers should add up to 12, right? Then I can have 1 here and 9, 2, 8, 3, 7, 4, 6, 5, 5, and then 6, 4, but 6, 4 and 4, 6 are the same, so this is ruled out. Also notice that 0, 2, 0 and 10, 2, 0 and 10 is already counted there, so this has to go. Also 2, 1, 9 will be here. 2, 1, 9 is already there, so that has to go out. So I have 1, 2, 3, 4 over here. Now let me start the next group of 3. So I will have 3 now, and then 0. Then I will left with 9, right? All right. Then I can have 1, 8, 2, 7, 3, 6, 4, 5, 5, 4. But 5, 4, 4, 5 are the same, so this is ruled out. 3, 0, 9 will have 3, 0, 9 is already there, so this is ruled out. 3, 1, 8. 3, 1, 8 is already there, so this is ruled out. 3, 2, 7. 3, 2, 7 is already here, so this is ruled out. So I have 2 here. All right. I'll start the next group. So I'll start with 4, 0, and 8. It should add up to 12. Then can be 1 and 7, 2 and 6, 3 and 5, 4 and 4, 3, or 5 and 3, but 5 and 3, 3 and 5 are the same, so this is ruled out. 408 will be here. 408 is here, so this is ruled out. 417 will be here. 417 is there, so this is ruled out. 426. So 426 is here, so this is ruled out. 435. So 435 is here, so this is ruled out. So 444, right? So I have one here, only one pair. Now if I let me do another group of here, I'll start with 507. So this can be 1 and 6, 2 and 5, 3 and 4, 4 and 3. But 4, 3, 3, 4 are the same, so this is ruled out. 507 will be here because I'm starting with 0 here, so this is ruled out. 516 will be here, right? 5, 1 and 6 is here, so this is ruled out. 255 should be here. 255 is here, so this is ruled out. 345. So I'm starting with 3 here, so 345 is here, so this is ruled out. So I'll be left with nothing there, right? So similarly, you can check the other. You will start with 6 and see that we will not get any more unique ones, right? So how many I have total? So 7, 5, 12, 4, 16, 17, 18, and 19, right? So I'll have 19 unique triangles. One thing I wanted to clarify. So I needed a group of 3 points and they need to add up to 12 because I have 12 points remaining, right? So the group can be, let's say, 2, 7, 3. Then whether it is 2, 7, 3 or 7, 3, 2 or 2, 7, 3, it doesn't matter. So these are all going to be congruent triangles, and that is why I have discounted many of the groups here if they have occurred before. Just a note. The triangle ABC is divided into 4 parts by 2 straight lines as shown here. The areas of the smaller triangles are 1, 3 and 3. What is the area of the original triangle ABC? Alright, if you notice here, these two areas are the same, but these two triangles have the same height. Then the base has to be the same, right? So if this is A, this has to be A, because area of a triangle is given as half base times height. And if the area is same and these two triangles have the same height because they share the same vertex, same height, so the base has to be the same. Similarly, if you look at this triangle, this and this, in this case, this area is 3 times this area, but again they have the same height. They have the same height, but the area is 3 times. So this base has to be 3 times this base, right? So if this is B, this has to be 3B. All right. Now, somehow we want to relate this area to this area, and let's see how. Let me draw a line here. Okay. We will use the same technique. Now, if I look at this triangle and this triangle, right? They have the same base and same height, so area has to be the same. So let me call this area X and this area is Y, right? So this area is X, has to be equal to area of this triangle is Y plus 1. Y plus 1, right? So that is the first equation. Similarly, now let's take a look at these two triangles, this and this. Again, they have the same height, but this triangle base is 3 times the base of this triangle. So this area has to be 3 times this area, and this area is X plus 3, right? X plus 3, that has to be 3 times this area, that is 3 times Y, because this area is Y, right? So this is the second equation. So we have 2 unknowns and 2 equations. We are all set. Let me substitute the value of X here. X is equal to Y plus 1. So this gives me Y plus 1. So that is the value of X. Then plus 3 is equal to 3Y. So this gives me, I take the y to the other side, so this becomes 4 is equal to 3y minus y is 2y. So this tells me y is equal to 2. All right. If y is equal to 2, y is equal to 2, that means x must be 2 plus 1 is 3, right? So x is 3, y is 2. Now we can just add the areas. 2 plus 1 is 3, plus 3 is 6, plus 3 is 9, plus 3 is 12. So the total area is 12. Two plane mirrors OP and OQ, OP and OQ are inclined at an acute angle. Diagram is not to scale. A ray of light XY, all right, parallel to OQ strikes mirror OP at Y, all right, here. The ray is reflected and the mirror OQ is reflected again and hits mirror OP and is reflected for a third time and strikes the mirror OQ at an angle R as shown. If OR is equal to 5 centimeter, what is the distance of the ray XY from the mirror OQ? All right, so this is the ray that is given to us. It gets reflected 1, 2, 3 times, and it's given to us. This is OR is 5, and what is given to us is this is right angle. All right. So for reflection, right, we should always remember one thing. So let's say this is a mirror. When a ray hits and gets reflected, this angle, let me call it theta, is always same as this angle, right? Or there is also another way to look at it. If I draw a perpendicular here, whatever this angle is, let me call it alpha. This is same as this angle alpha. So we should remember that for reflection. Now, given to us is OR, we need to find this distance. So let me just name some of the points here: A, B, and C. All right. So we need to find this distance YA, which is equal to D. Now, so we are going to end up with some same angles, right? So we should be thinking, we see a lot of triangles here. So somehow we should be thinking in the line of similar triangles so that we can equate the ratios. All right, so let's start one thing at a time. So another thing to note here is this OQ and this YX, they are parallel. So this ray is coming parallel to OQ. Then this angle, whatever this angle is theta, is same as this angle theta, right? Because OQ and YX are parallel. So if I have two parallel lines and if a line intersects, right? So this angle is same as this angle, right? So this angle is same as this angle. That's one thing to note. And we also just learned that, like, for reflection, this angle has to be same as this angle. So if that is theta, that is theta. Okay. Now, this is the same ray that is traveling, right? That means when this ray hits this mirror here, whatever this angle is, I don't know, let me call it alpha, has to be same as this angle alpha, right? Now look at this. Let's look at triangle OR and C. ORC, two angles theta and alpha, and let's take a look at this angle, triangle CB and Y. So there are two angles alpha and theta. So two angles are the same. So the third angle must be the same because they all need to add up to 180 degree, right? So if this is 90 degree, this also has to be a right angle, right? So that also has to be a right angle, right? Now look at this. The triangle, OR and C, ORC and CBY, triangle CBY are similar triangle, right? That means, okay, so this will help us propagate this distance 5 to somehow relate to D. Okay, so one more thing we need to think about. When this ray is getting reflected here, these two angles are the same, right? So this angle is same as this angle, but we just found out that this is 90°, right? That means, and they all add up to 180°. It's a straight line, so 180°. So this angle must be 45°, right? So these two angles must be 45° each, because this is 90° and these two angles are the same, so they both have to be 45°. All right, so we are getting somewhere. Now for a right triangle, okay, so if this is 45°, this angle has to be 45° too, right? Because this is right triangle, right? Similarly, this is also a right triangle, so if this is 45°, this also has to be 45°, right? So these two are right isosceles triangle. So for a right isosceles triangle, right? So this is 45°, and this is right triangle. So if this distance is a, this distance is a, using the Pythagoras theorem, this distance is going to be a square plus a square square root of that. That is 2a square square root of that is square root of 2a, right? So whatever this distance is, so this is 45°, this is 45°, so these sides have to be the same. So whatever the side lengths are, the diagonal is going to be square root of 2 times this. All right, now I think we are set. We already figured out ORC and CBY, they are similar. That means OR by RC, OR by RC, that has to be same as OR is the side in front of alpha. So in front of alpha, I have this distance YB, and then in RC is in front of theta. So in front of theta, I have CB, right? All right. So what is OR? So somehow I'm trying to propagate 5 to D, right? All right. What is OR? OR is given to us 5. Okay. What is CR? Okay. We don't know what is CR. So let me leave it there. CR is equal to YB. Okay. So this distance YB is going to be, see, this is a right isosceles triangle. So if this distance is D, this is square root of 2D, right? That's what we just figured out there. So this is going to be square root of 2D divided by CB. What is C? Okay, this is CB, right? Okay, so I know here everything except CR and CB. So this is CR and CB. But again, as you just figure out there, this is a right isosceles triangle. So CB has to be square root of 2CR, right? So CB is nothing but square root of 2CR, right? Because this is a right triangle, right? So CB has to be square root of 2CR, right? Now we are set. So CR cancels out, square root of 2 cancels out. So D is simply 5. So D is equal to 5. And that is what we are looking for, right? So we are looking for D, then C is the correct choice. Let mk be the maximum value of this expression here, or x in the interval -1 to 1 closed range, where k can be any real number. It can be any real number. What is the minimum possible value of mk? All right. So whenever you look at an equation like this, right, the first thing that should come to mind is this is a quadratic equation, the equation of a parabola, and parabola looks something like this, right? Now the coefficient of x square is 4, which is positive. That's why it opens up to the top. If this was a negative number, the parabola would look something like this. Now I'm looking at a range -1 to 1, and I don't know where that range is actually, but let me just assume that it's something like this. This is -1, this is 1. Okay. Now, whenever we talk about maximum value or minimum, we're talking about maximum minimum, right? So there are 3 points, there are 3 key points I need to keep in mind. Track this boundary, those are the 2 boundary points, and then the tip, right? So those are the 3 points that I need to track, and then I'm all set. I don't have to track every point. Those 3 points are enough, right? Every other point is between those 3, right? Okay. Now, how do I find this point here? How do I find this point? So this is let's say this is x, this is -1, 1. How do I know this point? So the equation of a parabola, general equation of a parabola is ax square plus bx plus c, right? So this is y is equal to this. Now at this point, the slope is 0, right? So if you know calculus, this is a very simple derivation. Otherwise, you can just remember the last formula. So I need to set dy over dx, right? So that is the slope to be 0. So this gives me, this is 2ax plus b is equal to 0, and this gives me x is equal to -b over 2a, right? All right. So this is the tip. This is the position, x position of the tip, -b over 2a, right? So again, if you know calculus, it's a very simple derivation. You don't have to remember. You can derive it very quick. If you do not know, if you have not studied calculus yet, it's a nice thing to remember. The position of the tip of a parabola is -b over 2a. So in this case, what is this value? -b, b is -4, so the negative becomes +4. 2a, a is 4, right? 2 times 4, 4 cancels out. So this is simply half. So this point is half, right? So there are 3 points, 3 values of x I need to track. -1, 1 that is given to us, and the tip is at half, right? So let's keep that in mind. So let me evaluate this expression at those 3 points. So at x is equal to -1, right? So this is going to be 4 -1 square minus 4 -1 plus k, and this is going to be, so this is going to be just 4, and this is negative positive, so this is 4 plus 4, 8. So this is going to be k plus 8. All right. So then x is equal to, let me do half next. For x is equal to half, this is 4 half square minus 4 half plus k. So this is going to be, this is 1 by 4, 4. So this is going to be 1. This is going to be 1. And this is going to be 1 minus 2 is -1. So this is going to be k minus 1. All right. And then x is equal to positive 1. Then 4 1 square minus 4 1 plus k, and this is going to be, so this is going to be 4 -4, so this cancels out. So this is simply k, right? All right. So mk is maximum value of this expression, right? And I have and then we discussed that we don't need to keep track every points. If we just track these 3 points, that's more than enough. And those 3 points result in these values, right? So k plus 8, and then k minus 1 and k, and what the modulus of that, right? So if I just keep track these 3 points, this is going to be maximum of this, right? So that is what I need to find out. So mk is maximum of this. That's just given to us, right? And I need to find the minimum value of this, right? The minimum value of this. So this is a function in k. As you can see, this is a function in k, right? And the function is defined as max of these 3 numbers, and I need to find the minimum of that. So a very easy way to do that is, we can just plot it and see. It becomes very obvious. because these are linear functions in K, so it's also very easy to draw. So let me erase that part. All right, so let me draw the x-axis. Let me say this is 0, this is 1, this is -8. I want 1 and -8 because that's what I see here. Okay, so this is my K. On x-axis I have K, and on the y-axis I'll draw f of K, and f of K are these three functions, right? K plus 8 mod of that, K minus 1 mod of that, and mod of K. Let me first draw this. This is the easiest thing to do. So K, the f of K is mod of K. So from 0, when K is positive, it will simply look like this. It will go like this, right? When K is negative, right, mod of that is going to be positive. So this is negative K. This is simply K. That is my f of K. Now let me draw K minus 1 mod of that. Let me change the color. Okay. So K minus 1 is going to be 0 at K is equal to 1. When K is equal to 1 is 0, right? So that's why I've drawn this point here, K 1. And for K greater than 1, it is going to be simply like this. So this is K minus 1, right? K minus 1. And for K less than 1, the shape is going to be same as this. So this shape is going to be exactly same as this. It's just shifted to 1, right? So you can, this is something you can, draw yourself and verify. So this is going to be on the negative side, is going to be negative K minus 1, right? Because K is less than 1 here, right? So K is less than 1 here, so this is going to be negative, but we want the mod of that absolute values, that's why I have the negative sign there. Similarly, K plus 8, let me change the color again. K plus 8 is going to be 0 at K is equal to -8, that's why I have drawn the point -8 there. And then again, shape is going to be exactly the same, except this is going to look something like this. And this part is going to be K plus 8, and this part is going to be negative K plus 8, right? All right. So those are my, these three functions, K mod of K plus 8, mod of K minus 1, and K. That's how it is going to look. And M of K is basically the max of this, right? The max of this. And K is any real number, right? K can go all the way there and all the way like this. So if I come from that side all the way, so this is going to be on the top all the time, right? Let me change the color again. So now I'm going to draw this function M of K, which is the max of this. So max of this, when I come from that side, the max is going to be this line, right? So this line, right? But when I come to this point, now from this point on, max is going to be this one, right? So this is going to be my M of K. So this is my M of K, right? That's given to us. It's always the maximum, right? So if I come from that side, this is maximum, right? And from right from here, this becomes maximum. All right. Now, the question is, what is the minimum possible value of mk? So this is my function mk. It looks like this, a V shape, and I want to find this value, right? I want to find this value, right? So what is this value? Let me first try to find this value, the value of k, right? So what is the value of k? Basically, it is the intersection of this line and this line. And this line is given as k plus 8, right? K plus 8, that has to be equal to intersection of k plus 8, and this line is negative of k minus 1, right? So that will give me the value of k, right? So k plus 8 is going to be negative k plus 1. So I'll bring the negative k to this side. So there is 2k is going to be 1 minus 1 minus 8 is going to be negative 7. So k is going to be negative 7 by 2. So this is negative 7 by 2. Then it is straightforward to find this value, right? So that is going to be, I can substitute in any one. Let me take this this line. So that is let me just do it here. This is minus k plus 1, right? So I'm substituting the value of k on this line at this point. So that will give me this value, minus k plus 1, and k is negative 7 by 2. So negative becomes positive. So 7 by 2 plus 1. So this is going to be 2, 7 plus 2. So this is going to be 9 over 2, right? So this value, the minimum of this max function is going to be 9 over 2, right? And that is what I'm looking for. Then B is the correct choice. I wanted to mention one thing here. If you found this problem hard, you are not alone. It was hard also for me. All we can do is learn the different concepts and practice. Thank you. A certain game is on when the one player gets 3 points ahead. Two players A and B are playing the game, and at a particular point, A is 1 point ahead. Each player has an equal probability of winning each point. What is the probability that A wins the game? All right, so this is an interesting probability question. Let's see how to solve it. I have A and B. A is 1 point ahead of B, so A can be at 1 and B can be 0. Actually, it doesn't matter. A can be at 8, B can be at 7, or it doesn't matter. As long as A is 1 point ahead of B, it's fine. And I'll just put some mark here so that I separate the points. So on the first round, either A can get a point or B can get the point, and both are equally probable, right? So A can get the point and A becomes 2, B stays at 0, or B can get the point, so A will stay at 1 and B will become 1, right? And each path are equally probable. So this is 50% chance that I end up here, 50% chance that I end up here. So this is the first round. In the second round, right, either again A can get a point and become 3 and B will stay at 0, or B can get the point, so A stays at 2 and B becomes 1, right? Similarly, here A gets the point and becomes 2, B stays at 1, and here A stays at 1 and B gets the point and becomes 2. So what is the probability that I end up here? Is 50%, and again 50% it can go this way, 50% it can go this way. So 50% of 50% is 25%. So this is also similarly 25%. This is 25%. This is 25%. All right, and 50% is half, right? 25% is 1/4. All right, so I'll make use of that. Now there is a 50% chance I end up here. Sorry, there is 25% chance I end up here. Similarly, 25% chance I end up here. 25% chance I end up here. 25% chance I end up here. So this is the second round. All right. Now, if you notice here, A is already 3 points ahead of B, right? So from here, I think we can figure out the probability. So let me call the probability to be P. Now, what is the probability that A wins? Now, that will be equal to the probability that I end up here and win, plus the probability that I end up here and I win, plus the probability that I end up here and win, plus the probability of I end up here and then win, right? So probability that I end up here is 25%, right? So all four are equally probable. So that is 25%, right? So that is 1/4. So the probability that I end up here is 1/4. And if I end up here, what is the probability that I win? Is 1, because I already won, right? Plus the probability that I end up here is 1/4. That is 25%. But if I end up here, what is the probability that I win? If you notice, A is 1 point ahead of B, so I'm back to square one, right? So here also I started with A 1 point ahead of B, right? So if the probability is P, the probability that I win here is again P, right? So there is 1/4 or 25% chance that I end up here, and if I do end up here, P is the probability that I win, right? So that's what we are trying to figure out, back to square one, right? Similarly, here also the probability that I end up here is 1/4, and if I do end up here, this is same as this, which is same as this, right? So this is again P plus there is 1/4 chance that I end up here, and if I do end up here, all right, so this is this, this is this. So if I do end up here, what is the probability that I win? Now, if you notice here, right, the situation is flipped. Here B is 1 point ahead of A, right? So here B has probability P winning, right? Then A will have probability 1 minus P, right? They should add up to 1, right? So total probability is 1. So this should add up to 1. So if B has probability P of winning, then A will have 1 minus P, right? So this will be 1 minus P, right? Again, so this situation is exactly reverse of this, right? Here A has probability P of winning. Here B has the probability P of winning, right? Okay, now I have just one equations and one variables. It is easy to solve. Now, okay, so let me just erase this part here. Okay, so P is equal to, this is 1/4, okay, 1/4 plus this is 1/4 P. Okay, if you notice here, this is 1/4 P, so this will cancel out with this, right? So I'm left with 1/4 P and then 1/4. So 1/4 P plus 1/4. So this, so P, I'll bring this 1/4 P to this side. So 1/4 P. So 1/4 plus 1/4 is nothing but half. So this is 3 P by 4, right? P minus 1/4 P is 3/4 P is equal to half. So this will be 2. That gives me P is equal to 2/3, right? And that is what I'm looking for. What is the probability that P wins? It is 2/3, right? B is the correct choice. There is another very interesting way to think about this problem. Let me explain. This is a little bit more intuitive, this approach. So instead of considering individual points of A and B, let me consider the points A minus B. So points of A minus points of B. All right. So let me draw a number line. So this is 0, 1, 2, 3, -1, -2, -3. All right. So when the points of A minus B, right, is 3, A has 100% chance of winning, right? So let me, on the y-axis, I'll draw the probability. Okay. So when A minus B is 3, that means A is 3 points ahead of B. This is 100% chance of winning. When A minus B is -3, that means B is 3 points ahead of A. A has 0% chance of winning, right? 0%. So here I have 100%, here I have 0%, right? When A minus B is 0, that means A and B have equal points, then A have 50% chance of winning, right? A have 50% chance of winning, right? So this is 50%, right? Because A and B have the same points, so A has, and they have equal probability of getting a point, so it has 50% chance of winning. Now if you notice, this probability function is going to be a straight line, right? This is going to be a straight line, linear function, right? Then when a minus b, so on this axis I have a minus b. I'm plotting a minus b on this axis. All right, so let me just erase that from here. Okay, so on this axis I have a minus b, and on the y-axis I have probability, right? So again, when a minus b is 3, a is leading by 3 points. It has 100% chance of winning. When a is 3 points behind, b has already won, so a has 0% chance. And when a minus b is 0, that means they have both same points, they have 50% chance, right? So the probability function is going to look something like this. Then it is very easy to calculate. If a minus b is 1, that is what is given to us. A minus b is 1. If a minus, that means a is leading by 1 point. At this point, what is this probability, right? So I want to find out what is this probability, right? So this, as you can see, this is a similar triangle. This triangle and these triangles are similar. So this over this, so this is going to be a distance of 4, or so let me call this probability p, right? So p, this over this, so p over 4, this is p and this is distance of 4, is equal to this, which is probability of 1, right, over this is distance of 6, right? This gives me p is equal to 4 by 6, or p is equal to 2 by 3, right? So we get the same answer, but I think this is a little bit more intuitive way of thinking about this problem.